Hi makers, this is PowerBankX. It is built up by 4 cells that are similar to those in Tesla cars and can recharge your phone several times. But if the battery would run out, just press a button and 2 arms fold up, revealing a pair of solar panels that then charge the power bank. And now I will show you how to build it. Let's get started. So to make PowerBankX, you will need to collect some wires, a 1 and 10 microfarad capacitor, a 7805 regulator chip, 2 10 kilo ohm resistors, 3 buttons, 2 small servos, an Arduino Nano, a 5V boost circuit, a LiPo charging board, 4 18650 cells, all the 3D printed parts, pieces of nickel strips and 2 small solar panels. First, glue the cells together and connect them in parallel with the nickel strips. Solder a wire to both sides and secure it into the housing with hot glue. Next, I secured one servo's axis to the rotating hinge after manually turning the servo so it's rotated all the way inwards. I repeated this on the other side too. I placed the circuit boards in the housing, marked out the ports and cut them out with the nozzle of the hot glue gun, though I later used a hot knife instead. After exposing a small section of the battery leads, I soldered those sections to the output terminals of the charge board and secured it in place. I also added a power switch. Next, I soldered wires to the 5V and ground output ports of the 5V booster. I connected the very end of the positive battery lead to the module's input pad and a short cable to the ground and secured it with glue. I then soldered the wire from the module to one pad of the switch and battery's ground to the other. Following that, I positioned and secured the Arduino too. I soldered the wires from the booster module to the 5V and ground of the controller, though I later added a switch between the 2 boards' grounds for the powering of the Arduino. I inserted some wires and resistors through some previously made holes and made the connections to the switches according to the diagram. I connected the other ends to ground, 5V, D2 and D3. I then cut and stripped the servo wires and connected the brown ones to ground, the reds to 5V and the yellow ones to digital 8 and 9. After uploading the provided code to the board, I flipped the switch, pressed the button and the arms folded out, though we'll have to add some solar panels for it to be useful. And that is the next step. I used hot glue here as well, but I'm sure silicone would have worked even better. It seems it works perfectly. But now we'll have to make a charger regulator so the panels over 6V can charge the batteries. That is made by taking the 7805 chip and connecting a 1 and 10 microfarad capacitor to it according to the diagram. These little battery-like components smooth out the power flow for better charging. Anyway, I soldered a pair of wires to output and ground and 2 other pairs to input and ground. After adding a heatsink, I connected the output wires to the positive input pad of the charge board and to ground anywhere in the circuit. I isolated the exposed areas with glue and secured the top cover plate in place. I lastly connected the 2 pairs of wires from the regulator board to each of the solar panels and used heatsink tubing for isolation. Before painting, I covered the ports, panels and switches with masking tape. For color, I chose matte black to give it a stealthy look. The final result is pretty cool. It has Tesla Panasonic cells and solar panels which fold up like some sort of Mars rover. I also really like that despite its functions, it's still quite compact. I hope you enjoyed this video. Thanks for watching and I will see you makers next weekend.